and these models, what is your intuition of how hard alignment will be?
Like, I think so here's what I would say. I think with the current level of capabilities, I think we have a pretty good set of ideas of how to align them. But I would not underestimate the difficulty of alignment of models that are actually smarter than us, of models that are capable of misrepresenting their intentions. Like, I think it's something to think about a lot and to research. I think this is one area also, by the way. Like oftentimes academic researchers ask me what's the best place where they can contribute. And I think alignment research is one place where I think academic researchers can make very meaningful contributions.
Other than that, do you think academia will come up with important insights about actual capabilities, or is that going to be just the companies at this point?
So the companies will realize the capabilities. I think it's very possible for academic research to come up with those insights. I think it doesn't seem to happen that much for some reason, but I don't think there's anything fundamental about academia. Like, it's not like academia can't. I think maybe they're just not thinking about the right problems or something, because maybe it's just easier to see what needs to be done inside these companies.
Mm, I see. But there's a possibility that somebody could just realize,
Yeah, I totally think so. Like, why would I possibly rule this out?
yeah,
You
yeah,
see what I mean?
yeah. What are the concrete steps by which these language models start actually impacting the world of atoms and not just the world of bits?
Well, you see, I don't think that there is a clean distinction between the world of bits and the world of atoms. Suppose the neural net tells you that, hey, like, here is like something that you should do and it's going to improve your life, but you need to like rearrange your apartment in a certain way. And you go and you rearrange your apartment as a result. Did the neural net impact the world of atoms? Just
Yeah, fair enough. Fair enough. Do you think it'll take a couple of additional breakthroughs as important as the transformer to get to superhuman AI? Or do you think we basically got the insights in the books somewhere and we just need to implement them and connect them?
so I don't really see such a big distinction between those two cases, and let me explain why. Like, I think what one of the ways in which progress has taken place in the past is that we've understood that something had a property, a desirable property all along, which we didn't realize. So is that a breakthrough? You can say, yes, it is. Is that an implementation of something on the books? Also, yes. So my feeling is that a few of those are quite likely to happen, but that in hindsight, it will not feel like a breakthrough. Everybody's going to say, oh, well, of course, like, it's totally obvious that such and such thing can work. You see, with the transformer, the reason it's being brought up as a specific advance is because it's the kind of thing that was not obvious for almost anyone. So people can say, yeah, like, it's not something which they knew about. But if an advance comes from something, like, let's consider that the most fundamental advance of deep learning, that a big neural network trained with backpropagation can do a lot of things. Like, where's the novelty? It's not in the neural network. It's not in the backpropagation. But then somehow it is most definitely a giant conceptual breakthrough, because for the longest time, people just didn't see that. But then now that everyone sees it, everyone's going to say, well, of course, like, it's totally obvious. Big neural network. Everyone knows that they can do it.
What is your opinion of your former advisor's new forward algorithm?
I think that it's an attempt to train a neural network without backpropagation. And I think that this is especially interesting if you are motivated to try to understand how the brain might be learning its connections. The reason for that is that, as far as I know, neuroscientists are really convinced that the brain cannot implement backpropagation because the signals in the synapses only move in one direction. And so if you have a neuroscience motivation and you want to say, okay, how can I come up with something that tries to approximate the good properties of backpropagation without doing backpropagation? That's what the forward algorithm is trying to do. But if you are trying to just engineer a good system, there is no reason to not use backpropagation. Like, it's the only algorithm, really.
Mm. I guess I've heard you in different contexts talk about the need, like using humans as the existing example case that, AGI exists, right? So at what point do you take the metaphor less seriously and don't feel the need to pursue